First of all, welcome to the summit. This is really an awesome experience. If you made the keynotes this morning, what's happening in the industry to me is just really, really exciting. There's so much cool stuff happening, and so much of that is in the open source world, and it's just what we're doing. So we're right at this nexus of all the interesting and exciting parts of the industry. I'm Chris Wright, CTO for Red Hat, and what I'd like to do today is talk to you about some of the things that we're working on that aren't purely bound to our product world. It's also just looking at the open source innovation. And there's a bunch of folks in here who are from the CTO office, and there's a series of talks throughout the summit that will go into more detail. So I'm going to give you just the glossy kind of high-level overview of a bunch of things that we're working on. You'll hear more details later. And feel free to ask questions, and if I don't know the answer, we've got people here that can help help you get into the details. And with that, we'll get started. If I can get my, there we go, got to turn it on, reboot. Come on. Not going to work for me. All right. So if you look at what we do from a business point of view, we have this internal discussion. Are we an open source company, or are we an enterprise software company that uses open source as a development model? And we've really focused on that latter statement. And the difference is from a really big picture point of view, what we're doing is using an open source development model to build products and support those products in mission-critical enterprise environments. And what's important from my perspective here is the open source development model piece. I'll see if this thing finally synced. Yep. These are the three core areas that we're focused on. This is at a broad picture from a Red Hat perspective. We have a strong focus in the infrastructure, and that's something that it's where we came from with Linux. Powering up a variety of different underlying hardware architectures and heterogeneous hardware even within a single architecture. We have what we're calling cloud-native application platforms, which is an evolution of what we've been building for quite some time. So if you go back again to the starting point with RHEL provided a consistent application base. We brought in JBoss, so a whole set of Java and Java middleware that created this great application development environment and runtime environment. That's just continually evolved. And today we have a whole set of products and technologies that we're investing in that allow developers to build cloud-native applications. And then all of that is valuable, but can be complex and hard to use without some level of management and oversight and automation to kind of bring the complexity to the level of mere mortals, us humans, that are trying to deal with the infrastructure that we're building and the applications that we're building, which, if you think about it, today, everything that we're building, whether it's a Rev cluster or an OpenStack deployment or an OpenShift deployment or Gluster or Ceph or your own applications, those are all distributed systems. And distributed systems are fundamentally complicated. They're complex and hard to manage, so you need tools and automation to help you kind of tame that complexity. This is kind of our high-level view or high-level vision of what we're trying to build. So you heard in the keynote this morning about our open hybrid cloud story. This is just kind of a different take on what we're trying to achieve. And at the bottom, you see all the infrastructure pieces. So there's bare metal, there's virtualization, there's private clouds and public clouds. There's some software-defined storage and software-defined networking components that are really key to that infrastructure. Really important as you span across multiple clouds, for example. At the top, you've got applications and some level of automation. In the middle, you have an application platform. For us, that's Kubernetes-based, that's OpenShift. And the way I like to think about the OpenShift platform is it's kind of bridging between these worlds of infrastructure and application in a way that it creates a communication mechanism between developers and operations teams. So, we talked a lot about DevOps in the industry. DevOps means different things to different people. It's one of those buzzwords. And to me, DevOps, I actually prefer the term AppOps, where the idea is application developers taking some ownership in the application lifecycle and deployment of an application. The operations teams or the infrastructure still needs somebody to be paying attention to it. And with OpenShift, we have a platform that's spanning between the underlying physical infrastructure or virtualized cloud infrastructure and the application platform like OpenShift. So kind of thinking of that as there's a set of APIs and services, creates the communication mechanism between developers and the operations team so that as an application developer, you're telling the infrastructure what you need rather than the old school model of really trying to define your architecture and hope it maps to the physical infrastructure that's been given to you by IT. So this dynamic platform, I think, is really the core of what we're building at Red Hat and what we're building across with the open source communities, starting with Kubernetes. This is just a picture of how it all fits together. So this is looking at a different view of those layers, looking at kind of a product view. You've got all the management and automation down at the bottom, and you saw Insights this morning. Insights is something that we've been working on for a while, and with Insights, you could think of it as an aggregation of data that we're collecting from our users. That aggregation of data gives us the ability to see usage patterns, whether those are positive or negative. Something's failing or something's working well. We see those usage patterns across a large set of users. And initially, that was a tool that we used with more of an expert systems mindset, or somebody's really there to look at the data and build rules around what does that data mean. Today, we're seeing the potential and the power of using machine learning to really divine new insights out of that information that we're gathering from all these systems. And ultimately, this becomes a really amazing direction for how you can manage infrastructure. So that's something that I think is cool. We'll have a chance to talk about it a little bit later, and I'm sure there's breakout sessions specifically here at the summit on that topic. And as you go up the stack, you see the different footprints where we're focused not just on our own bare metal instances or our own virtualization, but we have the ability to span all the different public clouds, and there's a lot of exciting activity that you'll see this week in how we're working with our cloud provider partners. And at the top of that stack is real applications, and I think the applications are actually the interesting part. It's all about the app is a one way to look at it. Why is it all about the app? Well, I have yet to find anybody, well, okay, I have a couple exceptions. I have yet to find anybody that just builds infrastructure to consume electricity. The exceptions are cloud service providers, but that's their business. So they build infrastructure and then they sell it to you. And then Bitcoin miners, and that's a different kind of proposition there. But the application is what really matters. So the infrastructure is there in support of applications, and we've been in the same state for decades. We've never built infrastructure just for fun. We've built it in support of applications, and applications are there really on behalf of businesses. Businesses are trying to run their business, create new business. So it's applications that are critical. That's why we've been focused so much on this container platform as a place to host applications and create that independence from the underlying infrastructure, create that portability. Initially, that was across variants of x86 hardware, and today that's across all of these different potential ways to build infrastructure. I think what's interesting is as we roll forward, it's not just about the application, it's also about the data. And you've seen that already. There's a lot of discussion in the industry about what is data privacy, the value of data, the issues that we've seen with the current political landscape are highlighting where data is useful and valuable, but also where we need to pay close attention to how it's managed, what the governance and policies around it are. And ultimately, the combination of applications and data are most valuable for businesses. We see this more and more, and what that means is data processing platforms and, of course, the kind of big data, machine learning, analytics world that's been evolving over the past decade, really, is coming really to the forefront. So the applications are critical. The data plus the applications are really valuable. So when I'm talking to customers, the most common conversation kind of today is gravitating towards the data processing piece of the application landscape. So the whole purpose of this conversation is about innovation. So that last bit was kind of what's Red Hat up to in general. On the innovation side, you probably saw this morning in Paul's keynote the notion of where innovation is happening. And my view is that innovation today is fundamentally happening in open source communities. Open source communities are the center of the kind of gravitational force, as Paul put it, or what I think of it as the innovation engine for the industry. Everything that's exciting and interesting and forward-looking today is really happening in open source communities. Even when you look at large hyperscale companies that are building themselves new interesting either applications or businesses, inside of that is a bunch of open source technology. If you look at machine learning as an example, it's not a new technology. It's really come to the forefront in the industry today, and one of the things that I love about it from an open source development point of view is the community is very scientific. There's a lot of science involved in machine learning. And that scientific or data scientist or kind of sharing of information ideology that you see in academia is mirrored in open source development communities. When you bring these two together, it's just natural that this happens in the open source development communities. Similarly, distributed ledger technology started off really as a white paper, and a lot of activity there has been around building open source code bases and solutions around implementations for distributed ledgers. And I think part of that is you think about the cryptography involved and you want to understand how something is working. I wouldn't feel confident without some visibility into the implementation. But I think you see these fundamentally new technologies that are happening only in open source communities or really accelerating rapidly in open source communities. We're in there. It's core to who we are. So we're involved in these communities. Not all of those communities for us become products, but we still have to pay attention because we're building infrastructure, we're building application platforms. We have to think of these in the context of workloads that we support, technologies that we may use internally, and ultimately components that may become part of our product portfolio. So when you think of all this innovation, one thing I like to note is today there's about 80 million repos on GitHub. And as an open source development model, or as a company that brings products to market from an open source development model, we get associated with open source all the time, which is awesome because it's core to who we are. But one interesting side effect there is, well, I have this open source project, Red Hat, you should bring it to market as a product. And you can see, clearly 80 million repos isn't 80 million distinct projects. There's a lot of forking going on in some common code bases. But we can't productize all of that. Let's be practical. What we are looking for are those key components, those key technologies that are really going to be important from an infrastructure point of view or building the next generation applications. And that's where we'll put our focus. And then again, understanding where there's other technologies that are important for our customer base, either from a consumption point of view or just building our own, improving our own technology internally. So a way to illustrate that is we've focused at that lowest level of the stack with Linux. Linux is the core for everything. We also focus on platforms. You see a list of technologies: Ansible, JBoss, OpenShift, OpenStack, Gluster, Rev, Ceph. And then there's the broad kind of possibilities of projects out there, many of which are runtime modules for different languages or interesting different smaller projects that as a user you might find them really useful. And we're excited to work together in those spaces and identify the key technologies that really are going to become core technologies or components in the platform layers. So one way to look at it is innovation for us is natural. It's just happening around all the time. Our focus isn't as Red Hat being the core of innovation. We're not trying to inspire by ourselves all of the next new technologies. We may be the creators and inspiration behind some of those, but many of those are going to come more broadly from the industry. And our goal and our role in this whole ecosystem is to help, to advocate, to identify, and we sometimes use the catch the wave rather than make the wave analogy of we're looking to be right at the tip and forefront of where innovation is happening and identifying those key trends and really understanding and having dialogues with our customers about what the impact is for your business and what's valuable in each of these technology innovations. So if you look at what I think we're trying to do, there's a lot of focus on speed and agility. And to me, that's really a natural extension of what happens in open source development, where you've heard for years the mantra of release early, release often. The idea of rapid movement, iterative processes, getting quick feedback. That's really what businesses are trying to do today. So in a sense, I think businesses are adopting an open source model really for how they work internally, not just application development, but more broadly. And to me, every step in this sort of iterative loop needs to have minimal friction in order to maximize your speed or agility. So we're looking at ways of how we can eliminate friction from the system. How can we smooth the process? There's some obvious examples when we talk to customers who are going from application development to testing to production, and along the way, maybe they've even built infrastructure so you can automate how you create an image. You've got a CI/CD pipeline so you can push code from development into test and production. And then there's this awesome step in the middle, which is a piece of paper that's printed out with the checklist and the weekly meeting that's verifying that the content in an image is compliant with the security policy, and your pipeline comes to a screeching halt. And it's identifying those bottlenecks in the business context that are what's really valuable and what really speeds up the agility or ability to move into production for a customer. And I think generally that's what we're trying to do across the industry, is look for those bottlenecks, look for those points that create friction and smooth those out. A different way to look at that, which I'll talk more about on Thursday, is achieving excellence across a number of different pillars: the user experience, the operational experience, and the developer experience. And on the user experience side, it's not something that we've talked a lot about in the past. I think it's really important. User experience, there's a whole interesting kind of science with psychology, human psychology involved, of what it means to interact with an application. Today, applications are increasingly defined, I think, by our phones and the phone experience, the mobile app experience, which just by real estate and by kind of explosion of different choices, you really need to be simple, intuitive, personalized, and context aware. And the goal for an application developer is reducing the cognitive load of the user so that the user can really get straight to business, which might be a transaction or might be sharing of information. And from a business point of view, you're trying to attract and retain customers. I think this is important because one interesting area, if you look at personalized or context-aware applications, what's happening behind the scenes? There's a lot of data being gathered about who we are as users, and that data is being fed into machine learning algorithms, recommendation engines. So these simple apps behind the scenes are really complex, and it's a great application for this new technology. Making it easy to interact with an application, something like natural language processing enables more free-form interaction, text-based or even voice-based free-form interaction with an application. Again, natural language processing is a machine learning technology that today, with modern hardware and modern frameworks for developing these models, we're actually seeing these become very practical, and you're using it all the time, whether you're aware of it or not. A simple search on the internet is powered, the PageRank and AdSense algorithms have been machine learning powered for years. On the operational side, we don't ever get away from the ilities. Availability, scalability, reliability, they're fundamental. IT shops can't just say, it doesn't matter, you may or may not get services. Security is increasingly top of mind, and all of the customers that we're talking to are really aware not only of the challenges in the security space and trying to understand what their risk profile looks like, but they're concerned about leaking data and being on the front page of the Wall Street Journal in a very negative way. So I have some background in security, so in a sense I kind of like that, although you see the stakes are really high and we really have to pay close attention to how we develop applications and help the application developers and the operations teams manage the security and risk profile around what they're building and deploying. Maybe the most important piece for me is as we build a platform, that platform needs to be able to support the broadest set of workloads. And that diverse set of workloads is directly proportional to the value of the platform. The more workloads a platform supports, the more valuable it is to the industry. Linux, I think, is a poster child for that. And this is why we're so excited about Kubernetes, because Kubernetes has sort of become the same type of Linux platform for distributed applications. So what we're doing, not just at Red Hat, but broadly across the industry, what we're doing with Kubernetes is trying to ensure that it runs the broadest set of workloads. You saw virtualization this morning with KubeVirt in the keynote. We are really looking at big data and machine learning type of workloads on top of Kubernetes. In the telecommunications industry, we're looking at running core network functions as containers in Kubernetes, and some of these require specialization of hardware features, for accelerating certain types of workloads. And ultimately, from an infrastructure point of view, having one distributed application platform that can host a wide variety of workloads will improve the operational efficiency so that you don't have to have a separate cluster for every kind of different workload that you're interested in, which we've seen in the past. So again, minimizing the operations team's cost, do more for less, and with that savings, there's the opportunity to then invest in kind of the new, exciting technologies. On the dev side, I talked about eliminating some of that friction. On the dev side, it's all about moving quickly, how quickly you can write code and get code into production. And I think of an idle developer as at best bored and at worst dangerous. I know the things that I've distracted myself with when I'm waiting for code to either compile or be ready to push out to a next stage, and ultimately trying to really improve that developer experience so that you're moving quickly, you're getting the iterative quick feedback so that the code you wrote is still fresh in your mind, I think is a key portion. Also, with a platform that's application focused, we take this app-centric view of the world. So we're no longer trying to define the application architecture by the infrastructure, we're defining the application architecture by how the application behaves. And the underlying infrastructure is just being told what to do and in support of the application. So scaling different instances, the application by demand, co-locating components so that we get optimal performance. That's really what we're striving for on the developer side or the application development side. In that context, applications are, they're big, complex beasts. And in order to be quick, we're trying to reduce the scope of things that a developer needs to pay attention to while building an application. And that's one simple way to view the microservices attempt of building reusable components and aggregating those components together to create an application. We've been at this for decades. If you think about object-oriented programming, it's the same idea. Build an object, it's reusable. Service-oriented architecture is kind of a refinement on that, and microservices continuing to refine that concept. Today, I think when you look at a small bounded scope service, there's a couple of interesting things. One, itself, it's small. Two, it's interacting with the rest of the system through APIs, so those other portions of the application are running as services. Those services may be developed in-house. They may be part of the platform, which would be where we're focusing. They may be third-party services. So you see things like the Open Service Broker giving you access to external services easily from Kubernetes. All of that is just helping the developer stay narrowly focused on building applications for the business. And if you think about it in a business context, it's every line of code should be providing value for the business, kind of an optimized view of the world. From our perspective, this is what we're focusing on. Development being business value as code, management being operations by policy, so really simplifying an operations view of the world, expressing higher level policies, and that platform in the middle supporting any application anywhere. That's fundamentally that's our goal, and that's what we're striving for. Getting into the OpenShift space, one of the exciting things here is how we can improve operational efficiency. Kubernetes itself, with a multi-site or federated deployment, gives you a single view into a whole distributed system across multiple clusters. And initially, without federation, you have all of these distinct Kubernetes deployments. Going forward in time, we'll see more and more effort around the multi-site or federation activities so that you can build these large-scale clusters with small independent internal clusters. Even in the cloud providers, they're doing this today. The larger scale clusters just don't really scale ultimately, and you've got specialization in different clusters, so really expressing functionality within each cluster I think will be really valuable, and it's why we're pushing in this space. And then automating how you operate an application as a service in Kubernetes with the operator pattern or operator model is a key area that we're investing in and something that you've heard about today in Paul's keynote, and you'll hear about it more this afternoon. If you look at reducing scope for the developer, this is my weak attempt at artwork showing, on the one hand, you've got a developer building an application on bare metal, the left-hand side, the heavyweight side. And inside that bare metal machine is an operating system, a runtime, a set of runtime dependencies for the application and the application itself. In some sense, the developer is responsible for that entire thing. And in the old days, even worse, the developer was responsible for that entire thing, and it was their workstation, and it worked one way, and then you put it into production, it worked a different way because you didn't have the same dependency chain, different patch levels of the operating system, et cetera. So a lot of responsibility is placed on the developer in that case. And when you lift and move that into a virtual machine, things don't really change fundamentally, except you get APIs around the lifecycle management of the virtual machine, so you get a little bit of improvement. If you move to a cloud style, that virtualization image might be immutable. So now you're starting to create separation between the operating system and the application, but still delivered as a bundle. Containers really formalize the distinction between the application and its direct dependencies and the underlying operating system. So we're helping reduce what the application developer needs to pay attention to. And if you take that a step further to serverless or function as a service, you're really, really focused on just your application logic. And this is reducing scope for the developer, helping the developer move rapidly. For us, we've been investing in the OpenWhisk project and ensuring that OpenWhisk runs well on top of Kubernetes so that ultimately the OpenShift platform plus a function as a service environment becomes an optimized way to build event-driven applications. And this, of course, from an open hybrid cloud point of view, means event-driven applications independent from the underlying infrastructure. really important for portability so that you don't get stuck with a single implementation of a serverless function like you can only use Lambda on AWS. Another really exciting piece from my point of view is not just microservices, but how they're connected together. So as you decompose an application into a set of services, you have to recombine them to build the application. And recombining them fundamentally is putting the network front and center inside the application. So we're with a number of partners and folks across the industry building a technology called Istio. It's a service mesh. And Istio kind of leverages work we already started with the Open Service Broker API and extends it to give the ability for services to register and register themselves and discover their service dependencies, gives service-to-service authentication and ultimately encryption. It provides a load balancer and proxy, and all of this sort of design patterns for distributed systems can be captured in fault handling routines in this abstraction or in this interposition between the service and the underlying platform, the network, providing quality of service, circuit breaker, retries, retransmission rates, et cetera, health checks, all of these things that if you ask an application developer to be responsible for those things, you're now saying, well, you need to be an expert in your application domain and a network engineer. And that's non-trivial. And really, the likely outcome is that somebody somewhere is going to make a mistake, or you're going to have inconsistent implementations of what do retries look like, or when do you avoid broken services with how do you implement a circuit breaker pattern. And bringing this into the platform means we're offloading a set of responsibilities from the developer to kind of the infrastructure. And again, reducing the scope and reducing what the developer needs to pay attention to, so you, as a developer, you can really just focus on writing code and building core logic, which is ultimately trying to do something valuable for your business. So moving away from things that we can build into the platform to things that we can run on top of the platform, it's hard to have a conversation today that's in the buzzword compliant world that doesn't include blockchain. And blockchain is something that we have a lot of conversations with our customers about, in some cases just trying to understand what are the applications, where is it interesting to you. In other cases, we're trying to redirect away from the hype and say it's not the right tool for the job. And in other cases, we're working to ensure that our platforms support this type of workload well. So you look across the possible ways that you could deploy a blockchain, and I like this, this diagram describing essentially like 4 different quadrants of how you could deploy a distributed ledger. In the upper left-hand corner, you have a permissionless public distributed ledger. And this is, common for currencies, cryptocurrencies. In the lower right hand, you have permissioned and private. And for us, focusing on an enterprise set of users, this is the more logical quadrant for us to pay attention to. And what's interesting there is in a permissionless public scenario, the threats that you have to pay attention to, what you need to do to build consensus, the consensus algorithm, fundamentally different than in a permissioned private scenario. So you can actually do performance trade-offs in your consensus algorithms to make distributed ledger technologies potentially useful for a different set of use cases in the enterprise than in that public scenario. So we're focused in that space. We've been working in the Hyperledger project, for example, leading the performance working group to ensure that we understand the performance characteristics of Hyperledger projects running on our platforms. And we work more broadly with an ecosystem of partners, having built the OpenShift blockchain initiative so that we can provide commercial support to a set of create a set of solutions on top of OpenShift with our partners, with one example being Block Apps. Block Apps plus OpenShift gives us the ability to create blockchain as a service for our customers. And it's pretty early days, I think, for distributed ledgers, but it's clearly got potential for a certain class of problems. And we have a lot of interest from a lot of customers trying to understand what does this technology mean? What are the impacts? You'll have an opportunity to hear more about that today. And I think probably one takeaway is distributed ledger does not equal distributed database. And think about it from that point of view. Also, buzzword compliant AI and machine learning and deep learning. These are not just hyped areas of the industry, but really interesting and exciting technologies that are actually old. They've been around for quite some time. And there have been some consistent breakthroughs. I think a lot of that is in usability, making it accessible, making it easy to consume. Part of that's on the hardware side, part of that's on the software framework and platform side. I think it's fundamentally changing how we solve problems, looking at problems from the point of view of data and trying to analyze data as the source of understanding for what's going on in a system. It was maybe 5 years ago I was listening to a scientist talk about how they were using machine learning to understand some problem in physics. And the frightening thing was they had been at this for quite some time. For a long time, the systems were inadequate, so it took too long to crunch through, do model training and crunch through the data. Finally got into systems that were able to create predictions and try to understand the system they were modeling. And the results were they couldn't understand the model that was being generated. So from a pure physics and science point of view, the machine had outsmarted the humans. And so I guess we're building the future that is Skynet or something like that if you really want to be paranoid. But what's interesting, I think, in a more practical world is the ability to take data and derive real insights from that data is practical and happening today. And our focus, while we're not known as a machine learning company, our focus is on enabling those workloads. Like you saw with blockchain as an example, how we enable workloads on top of our platform. And one of the things that I like about machine learning is its applicability to the industry has risen in part because of changes in hardware. And hardware enablement is core to what we've been doing all this time with Linux. So GPUs and FPGAs and hardware acceleration techniques for model training and model inference fall really smack dab in our kind of core competency for how we can support next generation application workloads. And so that's been a core focus for us. As I mentioned earlier, all of this is happening in an open source community, so we're partnering with folks like Google on the Kubeflow project to work through what does it mean to lifecycle manage a model. We understand application development, we understand revision control with code bases, what does it mean for models and parameter changes in models. So this to me is a really interesting space, and we've been working in this as an industry for quite some time, and machine learning, AI, sometimes it's confusing. What does the terminology really mean? I think of it in terms of a spectrum, and at the one end you have sort of unsupervised learning, cognitive systems, intelligent systems, a lot of different terminology out there, and at the other end you have pretty simple linear regressions and summary statistics. The far end at the left has been something that we've been doing for quite some time, and moving towards the right is where we're going, so we can really discover over time rather than identify kind of understood patterns. For us, it actually has a number of different implications. So first, the GPU enablement and make sure it runs well on our platforms. We're identifying that as a workload, something that we care about running on top of our platforms. We also see this as core to our business, as many of our customers do. So internal back office functions that can be optimized through data collection, and machine learning for market analysis, for under sentiment analysis, how are your employees doing? A lot of interesting applications internal within a business. You saw insights in the demo this morning. that's an example of us making use of that technology internal to our product. So not necessarily we're delivering it as a product, but we're delivering a solution with machine learning built inside. And then ultimately, we're trying to build a platform that enables you to build applications that are intelligent applications that are taking advantage of the data that you're collecting and building models and training and inferring predictions from those models within your applications to build more, the better, more valuable, business valuable applications that I described earlier. So I think if you look at what we're doing and in general, what we've been up to is building platforms that enable you to continue to run your legacy applications, build today's applications on that same platform, and be prepared for tomorrow's technology changes and evolve with the technology landscape so that as you're building new functionality in your business, you don't have to abandon the platforms and the investments that you've made in the past. And I think this is really the power of open source and open source development and kind of iterative processes. And it's been a core focus for us from the beginning, and we just continue on that path. Just checking the time here. All right. To me, I've been spending time in the networking space, and this is an interesting area that kind of ties together a few different themes. 5G and mobile edge computing creates a new space where you can run applications at the edge of the network. Some people call that edge space an edge cloud or fog. And in that context, you're feeding data from devices, sensors. It could be video content coming, whether it's surveillance cameras or other kind of cameras, just capturing state, feeding that into a network that with 5G provides low latency and high bandwidth connectivity, really combating wireline speeds, and dense connectivity within a single location. Putting applications close to that data at the edge means you have an opportunity to do data analytics. And at the edge, you have a constrained environment. It's a small space. You've got power constraints. So building on new architectures, ARM becomes interesting in this context, utilizing GPUs to do data processing so that you can sort of cut out some core bits of data right at the edge before you feed them back to your centralized data stores is something that I think will really change how we build applications over time. So this is an interesting area. It's something that we've been working on more from a telecommunications industry point of view, but I think ultimately it will impact how applications are built and delivered and where data flows go through the networks. I guess another piece is with that constrained environment, things like containers and serverless become really important. So you've got data feeding in from the edge, creating the potential for event triggers, the overhead of a full emulated system in a virtual machine potentially doesn't fit well in that constrained environment, plus the power consumption and kind of constrained physical environment that you have at the edge. So really a different space. Hardware, again, becomes interesting, and we're building the platforms that kind of bring applications into this space. On the networking side, you don't always think of Red Hat in the networking context, but you've got to understand that networking is core to who we are and what we do, whether it's as simple as a TCP/IP stack in a Linux host as an endpoint on the network, pretty fundamental, or with any of the distributed platforms that we build like Rev and OpenShift and OpenStack, networking functionality is an intrinsic feature to those platforms. So creating network overlays, managing the network connectivity between virtual machines or containers or components in your application is really important. And one of the things that is interesting to me is how do we connect these applications across the hybrid cloud between different data centers and between different public cloud providers. There's a lot of different possible ways to do that. We can manage that today with more static infrastructure, and I think over time we'll see really dynamic connectivity policies associated with networking across this multi-cloud space. And security. This is something that if you think about what we've been doing at Red Hat since the early days of RHEL, we focused on things like compliance and certification, EAL4 for RHEL, and using mandatory access control systems like SE Linux to confine network-facing services on the platform. That's just a tip of the iceberg for where security matters for you today. Containerizing an application gives a new opportunity for how we define the security boundary of that application, and then the network connectivity and the security policy around how applications talk to each other is also important. How you build images, how you create content and deliver that out into your network, understanding that that was meant for test, not production, and tagging it as such, so it's got different keys and credentials. All of these things are important security considerations that we're paying attention to, and we're really trying to help make it easy to deploy systems where you can understand the security profile of that system. One way to look at this, and I think Mike Bursell is here, he's in the back. One way to look at this is security today requires a holistic or systems view. So no single component will provide security for your system. It's the aggregation of all those components and the weakest link in the chain that you have to pay attention to. I've always thought of it from host security, application security, identity management, authentication, and network security, comprehensively creating your security profile. And that is sort of a systems view, understanding holistically what each step in your development process looks like and what it contributes to your security risk profile. I think I'm out of time, so I'm going to go ahead and skip to the end. There's a whole set of talks today in this kind of track of the CTO office where you'll get to hear in much more detail about what we're up to, and hopefully this is just a taste or a tip of the iceberg for those to entice you to come see the rest of those talks. And I hope you have an awesome summit. I'm really excited about this one because it's the biggest one we've had. Each year they get bigger, and the feeling of enthusiasm, which to me was really palpable last year, is repeating and kind of expanding this year. And I think it's because of this open source innovation coming together in a way that you can see all the pieces start to matter and build on each other. And we're doing this not just Red Hat, but we're doing this across the industry. We're doing this with you. So hope you have a great time, get involved, and look forward to talking with you for the rest of the summit.